Hi everyone, so in this tutorial we're going to look at how to create an enemy. I'm now up to lesson 5 enemies on my GitHub, so if your code is not up to date, just jump into that lesson. Where we're up to in the last lesson was we had it so that we are able to shoot snowballs, but we don't have anything to shoot them at the moment, and we haven't got any collisions going on either. So you can see I can shoot my snowballs. Once they go through the ground and they're actually into a negative Y position, they're destroyed. Right, so to create an enemy, we're going to have to create an entity for it. So if you look at my files, I have created a file called snowman.py. And one of the things I do is when I actually create this file, I'm also going to import that global vars file where I have my global variables. In that way, I've actually got the ability to access the game itself or the player. Now, I think I did the same in the snowball file that we looked at last lesson. You can see that I've actually got that there if I need it. Right, so to go into snowman.py, we are going to create a class for the snowman, and it's going to inherit from the entity object. We then need to define an init function. And in our init function, we're going to choose what values we want. You can see I've got 2 variables here. I actually am going to give them a default value. So just for the moment, I will create a default value for them. But obviously I will be passing in values into those areas. Those values are going to be replaced by vector3 or a 3D vector. The other thing I need to do is I need to use the super init method, because that will run the initialization of the entity object. And I'm going to pass in the position, I'll pass in the rotation, and I've found a 3D model from Sketchfab called snowman.gltf. In terms of how fast my snowman will go, I'm going to say, well, we'll make self.speed as 3, but we could always increase that. And the next step is whether we create a default collision, which we could have. So I could always say collision or collider is equal to box. But because we have brought in a 3D model, it's better if we actually create a proper collider object. So we're going to create a custom collider, and you can see the values I've got based on my 3D model. And as I was saying, when you bring in a 3D model, sometimes you'll want to sometimes you can't see what the box collider is. So sometimes what I'll do is I'll actually create another entity, and I'll actually put that entity inside the snowman entity, which you can do with any entity in Ursina. In Ursina, you can always put objects, entities inside other entities, which is useful. I've seen some tutorials where they put like a gun inside the player controller object. The only thing you need to do if you're going to do that is you have to say parent is equal to, and you need to feed it the entity that you're attaching it. In my case here, if I'm going to have a collider box as an entity, I'm going to attach it to my snowman entity itself. All right, so you can see I've just created myself a bit of a demonstration collider box, and we'll see what that looks like before I get rid of it. I'm going to set the scale of my model. Notice that I'm using -1 in the Z position, which means I'm going to flip my model. And I'll leave the snowball for the moment. And I'll just put in a return. So to make sure my indents are aligned properly. All right, and that is going to create my snowman entity for the moment. And then the next step is how I actually add that to the game. So I've created my snowman entity, but I need to add it to the game. So what I'm going to do is I'm going to go into the game itself, and then we'll make it so rather than inside the loading area, we're going to do it inside the start game, and I'm going to create a function called spawn entity. So inside my game, I'm going to have a function called spawn entity enemy. Sorry, and if I go to that function, we're going to define the function spawn enemy. I'm going to check that when this function is called, that the state of the game is actually the game. If it's not, I'll quickly return. So one of the things about my game object is I'm trying to track the state of the game. So when start game is called, self.state is equal to game. Likewise, when loading is called, self.state is equal to loading. So I'm just trying to ensure I keep track of where in my game I am. So that's just a quick, if the spawn enemy is the game's not running, quickly returns. Otherwise, I'm going to actually spawn an enemy, and just ignore my commenting for the moment. I'm just going to create a snowman. And to create the snowman, I'm actually going to create a position for it. So the position will be, and you'll notice this vec3 object. That's simply saying it's a 3D vector. I actually don't need it there, but if I want to ever add vectors together, making sure it's a vec3 object helps. So I'm going to create a random position on my screen. I'm also going to create a random, the snowman itself. So once I've created the random position, I'm going to create the snowman itself. And we need to make sure at this point that we have imported in the snowman object. So right at the top of my screen, I'm just going to make sure I have imported in the snowman object. I don't know why I've got the bat there at the moment. So from snowman, import the snowman object. And then going down, spawn enemy. If the state of the game does not equal game return, the position is equal to 3D, is a vector 3D, and I've given it a random X and a random Z position. And then I've said the snowman's position is this. So, and then I've just given it a default rotation. So I'm creating the snowman entity at this point. Now, that's only going to spawn one enemy at the moment, which at the moment will be fine, I suppose. But what we want to do is we want to make it so that this spawn function will basically keep spawning new enemies. Now, the easy way to do that is to use the invoke function. I'm going to say invoke self.spawn enemy. So basically call this function, and I'm going to give it a delay of 2 seconds. So what's going to happen is this function will run, and then it's going to call the function itself again every 2 seconds. So every 2 seconds, it should create a snowman at a random position. Okay, so we're ready to run this. I'm going to press play. And remember, we've also got the collider box on the snowman at the moment. I will get rid of that after we've worked out whether it's working or not. But when you create a 3D model and you bring it in, making sure that the collider box matches up is pretty important. So you can see these snowmen are actually spawning, and you can see the collider box there. I just want to make sure the collider box fits the snowman. I'm not going to worry about its arms so much. All I really care about is that the collider box fits. And you can see that I can't run through my snowman. Right, so that's all working. And you can see it's just continuing to spawn snowmen. At the moment, there's like 20 of them. I'm going to go out of that now. And again, I'm going to turn off the music, because the music is making it hard to hear. So I'll just go turn off the music. I'll also put in that snow texture as well, because I did that in previous tutorials. So we've got our snowman. You could see that that entity I created is inside the snowman. I'm just going to get rid of that now. I don't need it. that was simply to test what this, I just wanted to see what the box collider would look like. And that was all. So I've got that now with my snowman. And what I do want to do though is cap the number of snowmen that is spawned into my 3D world. And the reason for that is every snowman that comes in is actually going to lessen my processing power and my frame rate. So I want to cap the number of enemies I have moving around in my world. Otherwise, eventually I'd run out of memory. So going back to the game.py file, I'm going to go to the spawn enemy. And this is where I'm actually going to add each snowman to a global list. So inside my global vars file, I created a list called enemy list. And what I'm going to do is every time I create a snowman, I'm actually going to add it to my enemy list, like so. So you can see globals.enemy list append. So it's going to add the snowman. I'm just going to change the variable name because I feel like it needs to be different. I'll call it S-man or E. Actually, you know what? I'll just leave it as E. I don't know why I'm being so fussy. Right, so at this point here, I'm adding it to a list, but I only want to add it if the list is less than 10. So I'm going to, at this point here, it is an empty list, and I'm only going to create this snowman so long as the enemy list is less than 10. So I'm only ever going to have 10 snowmen. The other thing we need to worry about is that you saw that occasionally the snowman is actually spawning. Well, occasionally the snowman is going to be spawning either on me or another snowman. So what we want to do is make sure that when it creates this random position, which is here, it's creating a random position. We want to make sure that random position is away from the player, because there's no point in playing a game where the snowman is going to spawn right in front of me. So I'm just going to make it so that when it creates a position, basically it's going to check to see if that position is a distance of greater than 10 away from me. So if the distance is less than 10 away from me, it's going to create another position. And that will make sure that by the time I actually create my snowman's position, it will be about at least 10 away from me. Now to do that, Ursina has a function called distance_xz. There's also a distance_xy, or just a distance function. And what these functions do is they take the two vectors and they determine the actual distance between them. So if you can imagine 2 points in 3D space, it will actually determine the distance between them, basically using trigonometry. And it's going to check that that distance is greater than 10. If it's not, it's going to create another position. And then it will do exactly the same thing again. So that's going to ensure that my enemy is never ever going to be basically on top of the player. All right, so I'm going to stop there. It should be working now. The only thing we need to be clear is that that's going to happen throughout the game. When we actually end the game, we want to actually clear the list of enemies. So to do that, you can see I've got my end game function. And when I call my end game function, I'm actually going to remove, for each enemy in that enemy list, I'm going to destroy the enemy and I'm going to clear the list. So if the game ends, I'm going to ensure that all the enemies are gone. There are, in Ursina, there's a way of doing this using clear scene, but if I do that, because I'm using a game object, if I clear the scene, it'll actually clear away my game object. So in this way, I'm going to make it a bit easier. So you'll notice that in my endgame function, I clear the list of enemies and I also destroy the player. Right, let's have a look at how it looks. Hopefully I haven't made a coding error. Alright, and you can see that now I have my enemy. My enemy is not doing anything, but you can see that they're spawning on the actual platform, and they're never ever spawning on top of me. Right. Okay, I'm going to end this tutorial there. I'll see you in the next one.